Good morning, students, and welcome back. I want to explain lesson 2.8, page 44 and 45. So let's start in lesson 2.8. First of all, suggesting ideas, investigation. Okay, I want to start. This is an inquiry, scientific inquiry, and you all know previously scientific methods start with asking a question, right? So I want to start in asking a question. First of all, Shima is interested in energy stored in fuels and food. He asked his friends what they would like to know. So let's see the question. There is a different question. Uh, for example, how much fuel will Africa need in the future? Which fuel is the best? Which country uses the most coal? And blah, 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 etc. So Shima looks at all question. He wonders how the question can be answered. So this question, there is two types of question. One type we can answer it in a scientific method, and one type it's not a science. Okay, so for example, I will give you an example answering different types of question. This is the first type of question. For example, do you like playing football? So this type of question, is it a science? It's a scientific question. It's not a scientific question. For example, the question number 2, why the ball is slowing down? So this is a scientific question, and we can write it as a scientific method, and we can do an experiment about it. We can draw out a conclusion. We'll discuss it later. So there are lots of different ways of finding answers to question using science, but not every question can be answered using science. So be careful. Not every questions we can answer it using science. We can answer it using logic, whatever, our opinions, but science, not all the questions we can answer it using science. Okay. Now, the scientific method. This flowchart shows how some scientists think about answering questions. So this is a way that scientists use to answer the question. First of all, we have a question. This is the first step. The second step is to make a hypothesis. What is a hypothesis? Yani make a prediction. It's a prediction of the solution or the experiment, whatever. Now, to test this prediction, we collect data. For example, we can do it by an observation, or we can do it by making by doing small experiment. Okay, this is how we test the prediction. We want to see if our hypothesis it's working or not. So if we test this prediction and that does the data reject the hypothesis, so the hypothesis, is it correct? If it's not correct, no, I want to come back to the question and draw out another hypothesis, make another prediction, and then make another experiment or another observation. So I want to repeat my work by using different hypotheses or different question at all. But if the data accept my hypothesis, so yes, I want to draw out a conclusion, and after draw out a conclusion, I can publish this results. Okay, what the meaning of publish? I can I can give the result in such an official way. Okay, so this is how we discuss the answer of a question, or how to answer a question. Make it simple style. I want to give you an example. Which fuel heats up water? Okay, for example, this is the question. Which fuel heats up water the fastest? Okay, so this is the question. What is the prediction? Maybe the solid fuels store more energy, so will heat up water faster than the fuels that are gases or liquid. So the type of fuels that are solid, maybe it's faster than the gases and liquid. This is a hypothesis. Okay, so what should I do? I want to collect data. I want to test the hypothesis, test the prediction. This is my prediction. I predict that the solid fuels is fastest than the liquid and gaseous fuel. I must to test it. So how to test the prediction? Do an experiment. In this case, I will do an experiment to measure the time that it takes. For example, candle wax. Candle wax is a solid fuel, and ethanol, which is a liquid fuel, and gas, which is a gaseous fuel, to heat up 50 centimeters. So I will use these types of fuels to heat up 50 centimeter cube of water, for example, from temperature 20 degree to 50 degrees Celsius. Okay, so after this result, after I do this experiment, I will draw out a conclusion and measure the time. If my hypothesis is correct, so I will write a conclusion. If it's not correct, I want to come back to the question and ask a new question or a new prediction or hypothesis. Is it clear? Now, what is a practical investigation? What is a practical? You can collect data by doing an investigation. This is an experiment where you change only one variable and keep all the other variables the same. For example, now, in my example, okay, in my example, when I collect the data, okay, when I test the prediction or test the hypothesis, I take a candle wax, an ethanol wax, a gas, three types of fuel. So the fuel is a variable, right? What is the volume of the water? The volume is 50 centimeter. I want to change the volume? No, I will keep the volume constant. I will keep the temperature constant, and I will deal with the types of fuels. So I change only one variable and keep all other variables the same, just to know if the hypothesis is correct. Okay, so I change only one variable and keep all the other variables at the same. For example, if I want to test the density of the water and the density of the solid and the density of the gas, okay, I will get the same mass. I will get the same mass with different volumes. So where is the variable here? The variable is the volume. Why? Because I change the volume and I keep the mass constant. Okay, and then I will check if the volume will affect the density or not. This is, for example, it's an example only. So in any experiment, as a conclusion, in any experiment, you should change only one variable and keep all the other variables the same, constant. Okay, is it clear? If you have any question, just go ahead and send it by WhatsApp or by email. Now, let's see how we answer the scientific question. You can read the last part, page 45, not the last part, the last paragraph. I mean the last paragraph. The paragraph and the flow chart. Please read it, and if you have any question, just let me know. This is the lesson 2.8, and I want to explain 2.9, but before I explain 2.9, please go ahead and solve the summary question. When we finish 2.8 and 2.9, we can go ahead and solve the workbook, because 2.8 and 2.9, they are related. Okay, they are inquiries. Thank you.